Hello, let's look at another example of first order linear differential equation. And this has a initial condition. So let's proceed. As you can see, this is not in the standard position because the coefficient of y prime is not 1, it's t, right? So you have to divide both sides by t. So let's go ahead and do that. So let's divide both sides by t. So dividing both sides by t. So this cancel out. Here I can distribute this t. So I can write as 1 plus 1 over t equal to 1. So now we can see this is the p and this is the q. So let me write the p here and my q is equal to 1. So the first thing we need to find integrating factor, which is we call u. So the integrating factor is e to the power integral of p dt. That's the formula. So in this case, e to the power integral of my p is this 1 plus 1 over t dt. So the integral of 1 is t plus the integral of 1 over t is ln t. I have to put that absolute value, that's important. But because t is bigger than 0, I can drop the absolute value. So I can just simply write e to the power t plus ln t. Let's simplify. So I can distribute the powers. I can write e to the t times e to the ln t. Remember, when you multiply, you add the exponent, right? And you get the same thing. When you add the exponent, that is exactly what you get. But e to the ln t, that's just t, because e and ln are inverse function. So when you compose them, you should get t. Or you can think e and ln cancel each other. So you should end up with t. So what I have at the end is t e to the t. So that's my integrating factor. Once you have the integrating factor, now I can easily find y. So the y, let's write the formula. So something over something. On the top is the integral of u times q dt divided by u. So that's my u. So that goes here and here. And my q is 1. So my q is actually 1. So let's do that substitution here. So it's integral of u, which is t e to the t, times q, which is 1. I'm not going to even write that down, dt, divided by u. So we have to evaluate this integral here. Again, a quick reminder, when you do the integral for the integrating factor, you do not add any c, your c to be 0. But when you evaluate your y, you have to add c there, right? Okay, so let's actually do that. So this one is by the integrating integration by parts. So let's integrate by parts. So again, this eu and dv business, and don't confuse this eu with the integrating factor. That's eu is for the integral by parts. So this is completely different eu. So it's a temporary eu just for that integral. So eu here is t, dv is e to the t dt. So let's continue with the process. Du is the derivative of t is 1. So 1 dt. V is the integral of e to the t, which is e to the t. So uv minus v du, that's the formula. So let's write, in this case, my uv is t e to the t minus, sorry, integral of v du, apology. So integral of v, which is e to the t, and du, which is dt. And of course, the integral of e to the t is just e to the t. So what I have here is t e to the t minus e to the t. So that goes on the top. So let's do that. T e to the t minus e to the t, but don't forget plus c. You have to have that in constant of integration when you find out the y, divided by t e to the t. So this t to the t, if you want, we can distribute under each term. You are officially done for the general solution, but let's actually simplify. So I'm distributing the denominator under each term. So when I do that, this is just 1. This is 1 over t. So let's rewrite what I have. So I end up with y equal to 1 minus 1 over t plus c over t e to the t. So that's my general explicit solution. Now we have an initial condition, so you cannot forget that. So let's look at the initial condition. The initial condition is y of ln of 2 equal to 1. So let's do that. Y of ln of 2, y of ln of 2 is equal to 1. So that means when t is equal to ln 2, y is equal to 1. So let's substitute here. So I replace y by 1 and t by ln 2. Let's try to simplify this. Now, of course, e to the ln 2, that's just 2. Okay, so let's do that. And then I can subtract 1 from both sides. So there's, 1 is gone. So I get 0 equal to negative 1 over ln 2 plus c over 2 ln 2. And where I get that 2, that's my 2, right? E to the ln 2 is my 2. Let's bring this to the other side. Multiply both sides by ln 2. Then I have some cancellation there. So you end up with 1 equal to c over 2. So this means c is equal to 2. So let's go back and replace c by 2 there. So all I have to do, so now I know c equal to 2. So here I have to replace c by 2. So let's do that. So that's going to be my specific solution. So let me see. So I should write this arrow. So in the c, I have to replace c by 2 right there. So let's do that. So my final, so that's going to be my specific solution. Specific explicit solution after we use the initial condition, right? So it's going to be y equal to, let's see, 1 minus 1 over t, 1 minus 1 over t, and then plus 2 over plus 2 over t e to the t. And that's my final answer for this. Okay. Now, if you want, you can combine this to one and make it a fraction if you want, but you don't have to do that. Of course, here my t is bigger than 0, right? Uh, in that is given in the question, right? T is bigger than 0, because we use that t is bigger than 0 to drop the absolute value. Okay. I hope it helped, and always remember, you can do it.